Now it's your turn. Here are 5 examples. Number 1 and number 4, if you'll try those, pause the video, try those 2, and we'll come back and do those 2. The others are extra for you to try after that. Pause the video, we'll be back in a minute. All right, let's see how you did. One hint that I might give you is that notice that in this case, 3x squared plus 0x minus 27 is actually accurate. So when they have to be in descending order, that's a 0. And so if you got stuck on that and you don't know how to do it, now you do. So you can pause and now work this problem. But we'll go ahead and work this problem. The vertex, if I need to have the vertex here, what I'm going to do is I'm going to take and solve the function. And so what I'm going to do is it's minus b over 2 times a. So minus b is minus 0 over 2 times a. Well, 0 on the top automatically makes that 0, so I don't have to do any other math. So I've got that as a 0. Now the second one is the function of that. So if I put the function of 0 in there, that becomes a 0, that becomes a 0, and then this becomes, all that's left is negative 27. So there's my vertex. Remember, minus b over 2a was the function I was using. If I want to get the x-intercept, which means I'm going to make y equals 0. So basically, if I go back to this equation and make that a 0, then solve it. So if I keep the 3x squared there and move the 27 over, I'm going to have 3x squared equals 27. Divide by 3. X squared equals 9. Take the square root, that's plus or minus 3. So x equals plus or minus 3. So it's 3, 0, and negative 3, 0. Or I could have written it as plus or minus 3, 0 in one, but that's how they work out. So again, I've got my vertex, and now I've got my x-intercept. Let's get my y-intercept. To get my y-intercept, I'll write this in real quick again. That was that answer. This was plus or minus 3, 0. So in a y-intercept, I want to put in x equals 0. So if I put in x equals 0, that becomes a 0. So negative 27 is all that's left. There's all my points for that first one. In the second one, I'm going to follow the same pattern that we did when it's in this function. So when I want to find the vertex, this is the one that has the easy vertex. It's going to be that and that. So the vertex is going to be 3 minus 1. Becomes the answer on that one very quickly is 3 minus 1. Okay? So to get the rest of it, I have to multiply through. So if I take x minus 3 times x minus 3 minus 1, so that's going to be x squared minus 3x, distribute through minus 3x again, plus 9 minus 1. I'm going to get x squared minus 6x plus 8. Now, on the first answer that I got, I told you the numbers were so weird that we had to use the quadratic equation to solve. Always try to solve the easiest way you can. Can I solve this one like this? Positive, so that means they're both minuses, and 4 and a 2 give you 8, and add together give you 6. Set those equal to 0. X minus 2 equals 0. X minus 4 equals 0. So I didn't have to go to the quadratic equation because this actually factors out and works. It doesn't always do that. So there's my answers. So 2, 0, and 4, 0 are both of my x-intercepts for this one. Now let me go back and say that again. In the example from the first video, we actually had to use the quadratic equation because it wouldn't factor. Okay? So if you don't remember that, go back and watch that in the video previous to this. But in this case, it did factor, and if it factors that quickly, I've got it. So there's my x-intercepts. If I want my y-intercept, I'm going to go in and make my x is 0. So I'm going to make that a 0. That's minus 3 squared, which is 9, minus 1 is 8. So 0, 8 is my y-intercept. Now, here's the tricky part for some students. There's all the stuff I need to know. Okay? This and this are not the same. Y-intercept is where this picture crosses the y-axis. The vertex is the highest point or the lowest point, depending on if it curves up or curves down. It's the highest or lowest points. Don't get those two words mixed up with one another. You can try the extra ones for some extra help if you need it, but that's quadratic functions.